I am a earth science teacher at Plattsburgh High School in Plattsburgh, New York. I also teach astronomy, which is a true passion of mine. That's why I have my shirt on, space shuttle shirt. I actually got to go to a space shuttle launch as my high school graduation. It was one of the last, so that was really exciting. So today we're going to build a lunar model to land on the moon. So I am just going to kind of introduce it, show you what to do, give you a little background about Apollo missions, and then I will give you a little demo, and then I'll let you go. There is a big activity packet with this, with questions and writing activities and trials and science. So if you want, at the end of this, I'll tell you when, you can send me your email and I can send you the PDF file of it after, and you can use for it later. All right, so let me share my screen. I'm going to make sure I'm sharing it the correct way this time. Okay, and share it. I haven't used Zoom in a long time. Okay, so hopefully we can see everything. Is it big or small? You might have to tell me, because last time it was small and I did not approve of that. It's small. Okay, give me 1 second. I'll fix it. Stop share. Okay, big or small? Can you see it big or can you see it small now? See it big, big, big. Okay, it's okay. I just saw in the chat, you don't have all the supplies or anything. That is okay. You can kind of just do the modeling today and you can draw it out. And then another day, maybe tomorrow, you can do the actual activity. And again, if you don't have everything, you don't need everything. You can kind of just wing it today and then go on next time. All right, so teachers, if you have it, you're going to need rubber bands, paper, marshmallows, solo cup, paper plates. If you don't have everything, that's okay. You can use aluminum foil, you can use paper, you can use whatever. You can use eraser caps as your marshmallows. As a teacher, you can just wing it. It's okay, but I will send you everything you need after. Okay, so what does it take to land on the moon? As we saw earlier, the astronaut told us in order to do anything in space, it takes a lot of teamwork. It takes curiosity, optimism, self-control, grit, and gratitude. So you might find that it might not work the same way one time that it does another time. So you need some self-control, optimism, curiosity. You're going to try this many, many times. So I have a little video that kind of talks about what is going to happen when we go to the moon, which we found out today, 2024.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and crew reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew will reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignites the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned, and the crew aboard Orion coasts for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Alpha. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach, pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-raised systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out the halo orbit, and once again to sling the spacecraft around the moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented to heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our moon and prove that together we are ready to go beyond.
All right, so we are getting ready to build. So your steps for this: you need to create a lunar module to land on the moon with the following supplies. Again, if you don't have all the supplies, that is okay. You can just get a piece of paper today and do a model and draw it out, and then maybe test it within the next week or so. So if you have rubber bands, if you have paper plates, you definitely need some sort of like human figure. We're going to use marshmallows for that today. A cup, it doesn't have to be a red cup, it can be any cup. Paper, and then 2, you're going to test it. You're going to have a class competition who made the best model and see who saved the most marshmallows or whatever you have. All right, so I'm going to stop sharing the PowerPoint, and I am going to go to my camera, my other one, and I'll kind of show you like a little setup that we have here. Okay, can you see my hand or my paper? Yes, okay. Let me get this so my other high school students can see here. Okay, so you can see my hand. So this is kind of the science behind it, but you don't have to do this today. This is in the little packet. You design it, and then your trial. So what you're going to test: did your lunar lander land flat? First try, second try, third try. What height did you drop it from? The first try, the second try, the third try. What would you change next time in your first try, your second try, and your third try? You can write a reflection and check off the materials you use. again, you don't have to use that today. You could just kind of model what you were going to do. So you could, hopefully this marker works. If not, I have a different one. You could be like, okay, I'm going to use a plate here, a cup here, and do something like that and just kind of model what you're doing today. But if you have the supplies, marshmallow, cup, plate, rubber bands, paper, foil, and then you have to figure out how to build it. Okay, so that is what your team is going to do. So that's all I have for you right now. If you're going to model on a piece of paper, you can start that today. You can build it. You can build it tomorrow, whatever you need. So if you want, as a teacher, if you send me your email in this chat, I can send you the PDF files for this, and you can do it tomorrow. You can do it today. And then if you want to put the name, you're going to name your lunar module in, then we can help you there. I see somebody has a question, I think Jude or Lily. A paper plate will work. You don't have to use a paper plate. You can use just a piece of paper. Whatever works for your classroom right now. But other than that, you can go ahead and go out and go model and test and try and have fun. I don't know if I'd use a regular plate. It might break. You don't have to use all the materials. I can model it. I have some high school examples. I didn't build them. I had the high schoolers build it. And let me just pull my camera up more so you can see. So this is one. So you can kind of see that they have attached the plate to the bottom and they've added some like things to protect from wind. It's got two wings, foil, and then you can see their little marshmallow people. I don't know if you can see the little face there. And they kind of put some cushion in there. And then I have another one. And this one's cool. There's no top to this one. And then the side, you can see it's kind of open there. And some tape. And that's another model. This one's a creative one. They just kind of put everything in there and taped it shut. And then there was a parachute attached. But those are my models of where you could start. Yes, you can use that little sticky man. Just make sure I'm not missing. I can leave this as our picture. You're welcome. Have fun. If you put your name in, if what your class decides the name one, we like to see the fun names. Bye.
For the classrooms that want to stay on this Zoom and just work on the project with their classrooms, that's fine, because you can always put in questions into the chat if you have any for Hannah. But for those of you who do not plan on staying for the rest of the Zoom, thank you so much for coming to this amazing conference. We really wouldn't have been able to have made it so amazing without all of the students and faculty for participating in it. Today has been filled with so many amazing workshops, and I hope that you learned so many things, and we hope you loved learning more about science and listening to the astronauts in space during the downlink. For those of you, if you did miss the downlink, NASA TV will be broadcasting it again later tonight. If you didn't have the opportunity or you would like to watch it again, they decided to do a couple more runs of it. But today wouldn't have been special without all of you being here and learning, and the committee wouldn't have been able to do this without you. So special thanks from the Shine On committee. So thank you so much.
Thanks, Olivia. I'm still here. I'm just doing the email PDF.
Awesome. Thanks, Hannah.
Yep, no problem.